Hey guys, another one of the 10.2 homework videos. This time I'm doing question 3A. So let's get to it. So question 3A is how many grams of sodium are needed to produce 42.0 grams of sodium oxide? Now the first step is to predict the products. Now, I, being a cheeky jerk, have not given you the product, all right? This is a throwback to chapter, 7, ionic compounds. What do you make when you combine sodium and oxygen? Well, this is an ionic compound, so you got to crisscross. I'm going to do it over here. Sodium is a 1 plus ion. I know that because here it is on the first column of the periodic table. All right. And oxygen, I know. Come on, come on, come on. Oxygen, there you go, is 2 minus. I know this because oxygen is located in group 16, and all of these guys are 2 minus. All right, so crisscross applesauce, and the formula for sodium oxide is Na2O. All right, and now we balance this. All right, so 2 sodiums over here, 1 sodium over here, gonna need a 2. 2 oxygens here, 1 oxygen here, so I'm gonna have to put a 2 in front of that. But now we've got 4 sodiums, so I gotta put a 4 in here. So there we go. So this balanced equation is 4, 1, 2. Okay? And now we can begin the rest of the problem. All right, that was part 1, balance the equation. Part 2, I give you 42.0 grams of sodium oxide. Your first step in any stoichiometry problem is take your starting amount and convert it into moles. So here we go. We're going to start with 42 grams of sodium oxide, and we got to convert it into moles of sodium oxide, okay? Now to get out of grams and into moles, we divide by the molar mass, all right? So we got to figure out the molar mass of Na2O, sodium oxide. So I'm going to go here. I'm going to add a sodium, which is 22.99, plus another sodium, 22.99, plus an oxygen, which is 16. The molar mass of sodium oxide is 61.98. There we go. So 42 divided by 61.98. 42 divided by 61.98. And we get 0.678 moles of sodium oxide. Okay, next step. Now that we know the moles of sodium oxide, we have to convert that into moles of the final substance in this question, which is pure sodium. So we got to get out of moles of sodium oxide and into moles of sodium using the balanced equation. So taking this guy, boom, all right, 0.678 moles of Na2O. And we want to figure out how many moles of sodium is that going to require. So we got to get out of sodium oxide and into just plain sodium. And to do that, we look at the balanced equation. 4 sodiums and 1 oxygen gas give us 2 sodium oxides. So the number in front of the sodium is going to be 4. And the number in front of the sodium oxide is 2. So it's just going to be 0.678 times 4 over 2, which is just 2. All right, and that results in 1.36 moles of sodium. Now, the last step is, so Roman numerals here, make them more Roman. Nice. All right. We need to get our moles of sodium and convert them into a real world amount, grams of sodium. So we got to get out of moles of sodium, 1.36 moles of sodium. We got to get into grams of sodium. So out of moles into grams, you're going to multiply by the molar mass. What's the molar mass of sodium? Well, to the periodic table, it's just 22.99. There it is, 22.99. So 1.36 times 22.99, and you get 31.3 grams of sodium. That's how many grams of sodium you will need in order to produce 42 grams of sodium oxide.